Thank you very much. I'm Carol Phillips with Moriyama Teshima Architects. I'm also representing our collaboration with Acton Austria Architects. Limberlost Place is at Queens Quay Boulevard and Dockside Drive and next to Lake Ontario, and is the second of George Brown College's for waterfront buildings. At 10 stories, this exposed mass timber, net zero carbon emissions building is poised to be the first of its kind in the world assembly occupancy tall exposed mass timber building. It will house the schools of computer technology as well as architectural technology training and have a research center. The first spaces that you enter at Limberlost Place are the Learning Landscapes, a series of informal study rooms and common spaces for the students. There are 2 CLT clad feature stairs, one from levels 1 to 3 and a second from 3 to 6. The building is connected with a timber bridge to the existing George Brown College building. The typical floor plate are classrooms, and each classroom floor is bookended with what we call a breathing room, a small living room or crit space for the students. It also has a fitness center on the 2 lower levels and, as mentioned, a sustainability research center. The project reaches the 2030 challenge that Toronto has set for itself a decade in advance and has a very impressive sustainability target. It is also at a developing area along the waterfront of Toronto with an enhanced public realm, and the project has a teaching daycare to provide amenities for the neighborhood. Limberlost is under construction and was procured through an international design competition. Our competitors included Shigeru Ban, Provencher-Roy, and MJM with the Pat Cows, and I mentioned them because I really believe that mass timber innovation requires a community and sharing knowledge. Our concept was to really embrace the density and the compactness of fiber and to breathe room into this density. This idea of breathing room really embodies all the concepts of our project. We have structural breathing room, which means the structure is very thin and wide. And we have sustainability breathing room in that the breathing utilizes a natural ventilation system. And we have social breathing rooms in that we have deployed social spaces throughout the density of the building. Again, with clear access to the lake through a public park, the building is at a really important part of the Toronto landscape. So again, this very dense and regular grid, we have carved out of it social spaces, and not on the interior of the building, but on the exterior of the building to engage with this dynamic community and views to the lake. We found that despite the regularity, this judicious carving out of spaces has allowed us to create a variety of spaces and choices for students. Spaces that are more communal, spaces that are cozier, and even spaces that are more intimate throughout the population of the building. Students as well learn in a very neurodiverse landscape and therefore require different social environments to be successful in. The massing of the building is very purposeful as well. For our natural ventilation system, we have 2 solar chimneys, one on the east and one on the west. One heats up in the morning, one in the evening. And in order for the solar chimney to work, it has to stretch up a full 1.5 stories or 2 stories above the last floor that it is serving. So the building stretches up to the north to take in the softer artist light and then shuts down to the south to mitigate heat gain and to be an armature for the PV. This is a diagram of the natural ventilation system. There are times in Toronto where we have to close the windows. So the building will go into active mode and we utilize a decentralized mechanical system, which means the building has no central mechanical room, liberating all of the space for use within the building. The 2 rooms on every floor can be optimized using the building's BAS system so that it really can be fine-tuned to the building's needs. We can even shut off the floor if required. The building is protected with a prefabricated aluminum facade with integrated windows. And this way we can protect the timber as it's being constructed in the harsh weather in Toronto. The solar chimney, the double facade, has solar shelves in the middle of it to heat it up and create, through natural buoyancy, the convection required for the natural ventilation system. But it also functions in the active mode, washing the building with cooler air in the summer and closing up the vents so that the solar chimney creates a buffer of hot air during the winter, almost like a blanket of air around the building. And most importantly, though, the breathing rooms are just adjacent to these solar chimneys. And we feel that there is going to be an intuitive communication of the value and the operations of the building without being explicit to all of the building community as a teaching facility. The main star of the show, in a way, though, is the timber. It is a hybrid building. We have steel cores and we have a concrete basement and piles. And the structural system is deceptively simple. There are 3 components: wide columns that average between 1,200 and 1,800 wide, a very thin slab band that spans 9 meters in 405 millimeters, and then standard infill panels, that CLT infill panels between that. There's a diagram of the wide columns and their connection through the slab band, but I just want to take a moment and describe this slab band. It was designed and can structurally operate as an all-timber piece, but the reality is, because of the vibration criteria, this had to become a timber concrete composite system. And so what we have then is a timber concrete composite slab band that spans 9 meters in 405 millimeters. The system has been tested by FASTNEP, or structural engineers, with UNBC, and the research was overseen by Biberach University in Germany, and all of this is open source. We had an incredible testing regime, 60 pieces up to full scale, to test the way the concrete connects to the timber, and all of these results are open sourced. They're globally available because, again, we believe in order to proliferate the uptake of mass timber, we need to share information. We used angled screws, we used a proprietary system, and we used simple metal kerfs. Those metal kerfs actually were the ones that we ended up selecting. Again, this is all open sourced, text me. We will share all of this information, and it's for the global community. But again, why timber? We have a renewable resource. Until concrete and steel begin to massively decarbonize, we need to start, as architects, taking agency on the chain of command of materials that we specify in our buildings. And if there is certified wood, where there are forestry management plans, where there is renewal and regrowth, we have an opportunity here to look at a renewable resource for 20% of our building materials. And besides, we have the opportunity to have regional expression in our buildings. Our wood for Limberlost is coming from Quebec, and the black spruce is very close to the woods that grow in Ontario, and the characteristics of that wood are part of the characteristics of the land that we are building on. And again, under construction, and we'll keep you posted. And I just want to thank you for the time to talk about this incredible building. One last thing, I think perhaps the biggest tool in our sustainability toolkit is to try to change culture about how we as architects think about where our materials come from and our responsibility to the worlds of extraction or regrowth, but also to change the culture for the expectations of public buildings, and therefore have massive change in our communities. Thank you very much.